Okay, can y'all hear me now? Yes. Y'all can hear me. According to OBS. Okay, can y'all hear me now? Yes. Y'all can hear me. So this design is not by me. It is by Matt Bat. And because I
back to 0
can't make proper RAM, this is the best I could do. As you can see here, I made this room. But have no fear, I have the tutorial right here. Not on screen, but on my phone. But the idea of this one today is to basically store something. The goal is to store value that will now the goal is to store a value that will practically save. So we could turn on this one, it would activate and output a value. I believe these are all supposed to be in subtract mode along with these. One thing I really don't want doing, because I saw a video on this where some Redstone streamers, what they don't do is credit where they got it. So like, instead of, it's like all Sam did, what he would do is he made a door and he just didn't say who it was from, at all. I really don't know. I don't know why you do that, because I mean, people took time to create that so that you could view it and try it for yourself, and you just take credit, really. So whenever I try to make these, this is from a rec rap video. I recreated it by frame. This is the first prototype I tried, and as you can see it failed. Then I did rec rap's idea of splitting into lines, just that this is smooth spread across, to where we have the bottom right, top right, bottom left, top, and top left. Don't know why I forgot to put it in order, but that's the order. So if we want to, so what we could do here is, from a register from last time, which I hooked up here. Oops. As you can see, it refreshes, nothing else is on, it's working perfectly fine. Goes up here, and then we have our decoding, where we take our values here and decode them into our letter, which is A. Now, the fonts are not elegant, not one bit. If I show you B here, it will not look good at all. It looks like an 8, and I really don't know how I'm gonna get values all the way up here. That is something I'm still looking at. I know in the video where Brandy and Rockrap create the internet, what they do is they have a custom font, a ROM or something, which this counts as a ROM, by the way, because we're reading it only. This is pre-programmed. We can't just dynamically change this one or this one or this one. No, it's all set. So if I were to deactivate this and show y'all E looks good. There's no F yet, but I could show y'all how I encode it here. It's really simple, but you could already tell how I encode it based off of the layout here. By the way, this is the center part. I had to come up with a bit of a more creative way to attach it, but it works really well. So if you want to create F, we could copy E and just leave out a few parts, like the bottom here. We could take not that one, but this one, this one, this one. Put that on top here. Dust, lever, get a sign, and put F. And now if I flip this, this should be an F. Simple, right? Okay, so if we note that my mouse scroll is not working properly, so now if we take here, so here we have a RAM design that's also not by me, but at the same time also by me because it's modified. This is from the Brandsy and Recrap Creates the Internet video, and it basically is a replication with my own twist, because like here it is not the same. You have an unnecessarily long part here because I wanted space. This is different, I think, and it updates like how they fixed it, where it's 2 ticks, 2 repeaters. Because with 1 tick, I think it updates too fast. 100 ticks per second, it runs fine and seems instant. Just like when if I were to just come here and flip the lever, you can see how fast it went straight to A. And it had to pass through this, then go all the way over here, decode, then go through a bunch of these, just output this single letter. Next, the idea is we want to be able to store it. So like we want to be able to take a letter here, place it on, and then go to the next one, place another letter, shift to the next one, place another letter, and we also want to be able to delete it. So we go here, and so if we like here and we want to delete the previous letter, we jump back to this one, wipe it clean, and stay on this. Now my idea is with RAM, where we can dynamically change it here. Well, not dynamically, because one thing with Brandsy and Recrap's RAM is you can't dynamically access it, because I've made a prototype in a different program where you can access its cell address. So we could have a bit here. So let's say we have a 3x3 grid. Each one is 1 bit. So each one is 1 bit. And let's say we want to write to, this is cell A1 and this is cell C3. Let's say we want to write to cell A1 true, cell C2 true, cell A3 true, and cell C3 true. Now we can't just go and jump to it, because here's the problem. We're going in a straight line. We can't just go like this and just take the value. No, we have to manually wait till we get that value. We can only increment it and go forward by 1. So that's when I looked at repurposed memory here for RAM, where we can easily take a value and apply it there. Now the idea is to try and take these values and then spread it across a grid. And if I can manage to do that, then guess what? We got usable RAM that we could try to use for that. Because we can save letter A to that spot, save this to that spot. At the same time, we need registers for storage and stuff, especially with instructions. I haven't modified the ALU yet, and I'm actually looking into the CU, because I know how the APU works, not the APU, CPU and ALU works, but I don't know about the CU, which is the control unit directing the flow of stuff. So if we want to play Pac-Man, we have to have some form of way to say, if this is on, then go straight to this one, and if it's not on, then don't go to this one. And we have to be able to program that. So most likely we're going to do it with ROM, where we can save our values and then automatically read them based off of the input. So if we want to add, we can go straight to the CPU, or we could go straight to, let's say this is the ALU or storage. We can take our value, let's say we want to do ALU, then we can have some subcategory. Then if it's this, then do that, like stuff like that. Then we can do something like that, where if it's this, then this, not that. So like even the logic system, if we want to do XOR, we have to be able to flip this switch, do that, and in the first place we can change this to storage. So we need to consider all these things when making the computer. So what we're starting with, all right, now it's nice and bright. So yeah, now I'm going to try fixing this because I don't do this correctly, I think. Because we can write, and then if we want to read what we wrote, we can do that. But then I have to do a writing function, a clear function, because when you do computers in real life, you don't really have the ability to just shut it off at a moment's notice because that's not how Redstone works. So we have to manually create a clear function like this where it subtracts the values and then outputs them. So let me just get back the design here because I really don't know how to make this. Okay, so I'm on the right track with this time. So like this, if we want to write, I can program it. So let's say we want 1001, sorry, and we can write now. No, I don't think I did this correctly, but did I do it on the wrong side or something? I think I did it on the wrong side. Why you running? Like nothing happened. Okay, I see what I'm doing wrong now. So it's supposed to go like this for this part. Boom, 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 boom. Not supposed to head back there. Boom. So now, if we do that, then we go back a bit here, build up with a comparator. How about comparators in order here? Again, this design is not by me. It's by MatBat. And there we go. Put these in subtract. Put that there. Boom. This goes there. Pretty sure this is supposed to be something like a clear function. Then like right here, we build up, put this. I think it's supposed to be directly over something like this, and then we just go across. Then here we have another gap. And I'm pretty sure this gap is supposed to That felt really fast. Pretty sure this gap is supposed to go something like this. And then we place the dust here, torches. And then we put these one block out so that we can place the buttons and they will not affect them. So now if I finally remember to put the redstone dust, we now have one bed here. So we want to do that, and I'm pretty sure this is wrong now. Put that there, that there, that there, there, there. Let me set the tick rate back to normal. Oh, so this is supposed to be inverted. No wonder. And then like that. Yep, and our value is saved in writing. Then if we want to read it, I said then if we want to read it, we can place the comparators the correct way for that, I guess. Boom, boom, boom. If those comparators are facing the correct way. And then we place. Then that's clear. That's right. And then this is read. Okay, we finally got it working. So now let's duplicate this. Boom. Alright, now that that is done, let's just make sure everything is properly connected here. Alright, now if we want to input 1001, which should be 16 is that is 17, I think. 1, 2, 4, 8, sorry. That's 8. That's 9. Then we can write to it. Oh, torches. Why are you outputting? Then we can clear it if we want. Write again and read. Alright, we got a working RAM system here. This is, I'll take this as 1 cell of memory. So what we are going to do here is try to compact this as much as possible. Input, comparator, let's start off with 2 for now. Then we can immediately go to that. Boom, boom. This. Yep, then we have 1 directly over. And then we read these because we can't have them directly under there to read. Yep, and then we place a redstone lamp. Alright, so we have 1. I forgot to put the right function, and then we output that right here. Oh gosh, that's too close. So I'm gonna have to move this back by 1 for space reasons. Boom, 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 da, da, na, 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 na. Da, 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 da. Da 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 na 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 da 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 na 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 da da na da da na da da na 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 da da na da da na da. And we can clear that, and then we can I said then we can read. Or I could remember to put the redstone dust. Again, read. Let's go. Let's read. Let me check chat. Just do something. Why can't I add tags while the live stream is active? Alright, I got it. Alright, so okay then. Anyways, now that we got our circuit working here, we can work on incrementing this into something. This is basically round for those who don't know. And this design is also not mine. This is more dynamic than the monstrosity over here. Not monstrosity because it's good for the basics, but it's less dynamic. So we could have a stream of data like this. Then if I want, because here's one thing with this, if I want to, I could just let this entire thing flow like that. That's one thing, because you can store more in a more compact space, but this provides more functionality. So I'm thinking to add this to a display. So like I can take this entire thing, we'll add a few more lanes for each of the segments, and then duplicate that, across a bunch of segments so that we could read what's there, we can write what's there, we could write, and we can clear. For clear, I'm probably going to do it character by character or all at once, because I mean, if I want to get rid of the letter A right now, it has technically a very nice out animation, so I can do that. See, I could do that, and then if I want to get C, I could go through my ugly B here and then go here and C. And with tick speed at 100, it's a lot faster. So like I could get an A like that, a C like that, a B like that, and then you also have these levels which do kind of inconvenience me, but they do show the pixels there, which is at least good because I can see how fast they light up. So it's like milliseconds after I flip the level. So here we have our APU from, not APU, CPU, ALU from last time. And I'm looking to make it more compact because it may or may not be a bit big. And we want it to fit within this red space here. So if we have something as big as that and try to fit it in here, that's not gonna work. So things like compacting was done in the last time, so it's a lot smaller than previously, and that's very evident because it was more spaced out here, and here it's very compact. Now we do have the problem of it's very spaced out between each one, but that's also not a problem. The main goal is to try and get the entire circuit here as small as possible to fit in here. And currently this entire circuit here takes up this space, and going in circles is not an option because we also have to fit the logic. It's ALU, arithmetic logic unit, not AU, arithmetic unit. You have to be able to do multiplication, addition, subtraction. So I will be, again, look up tutorial. I know how it works, but I don't know how to make it. So we're probably going to be going upward, and the idea is to Add binary values. So let me just check stream chat in case anybody said anything. Hi Ray. So yeah, MacBag does have a helpful series, but not helpful in showing me a design. I know how to make encoders, decoders, I know how to make some displays. And I know that we could try making an entire display off of Redstone signals. So like if we want to make like a display, let's say 6x6. 1, 2, 3, 1, 2. Alright, so now we have a 6x6 display. I'm gonna make it 7x7. No, 7x6 instead. We have a 7x6 display. We can take torches here and actually make something. At least I think that's how it works. And for rows, it's kind of like signal strength here. Let me just collect all these torches. Alright, so if I want a signal, it's not, let me get a barrel. I love how Mojang has the barrel in due to the fact that a lot of players would use the barrel just for that. So now if I were to take a bit of distance here, wrong way. If I want the entire bottom row here off, I can do that. You saw nothing. I did not mess up or down. And then we can just repeat it with the entire thing up here. Wrong thing. No, this is just an idea. I don't know if this is actually tutorial, but currently I have my phone down and I'm not really watching it. So this is the idea for our display here. So let me just have my phone. The computer is getting bigger, a lot bigger. I had to troubleshoot the ROM here because sometimes you'd have me trying to get A, which is also the reason for refresh, which I now call a screen refresh because it kind of does that. I also finally labeled them so that I can easily pinpoint what is what. So like 1, 2, 4, 8, and soon 16. So we in fact can do 1, 2, 3, 4, that's 4, and 4 is 0, 1, 0, 0, 5, 6, 7, 0, 1, 1, 1, and then 8, 9, and as far as I've gone here, 10. Currently we have 10 values we could work with, and it gets slower the further away it is because of all these repeaters. And we in fact do also have our display here with the ugliest fonts known to man. We have E as one I'm actually proud of, C is 1, A is 1, B is not, D is not, F I am proud of. I am going to probably try redesigning this. But right now, we are working on a display here. So the idea is I can limit how much. So like right now I need more redstone lamps. I want, okay, so this is the low, this is the furthest. So I want this to be, I can't tell what is on, what it's off. Why did I get rid of my redstone lamps? There we go. This is too close. So if I want to get the first pixel, second set, third set, fourth set, fifth set, I'm probably gonna make this sixth set. So I'm gonna remove a couple lamps. So now this should go all the way to the end here. I said it should go all the way to the end here. Go all the way. Finally. Now we have an entire bottom row where we can control it via these values. Now we have an entire bottom row here which we can control. I give up. So here, one, all that. We got 7 rows here to correspond to 7 there. And then we could also try to encode it so that we can have this, then go up and then choose the value there. But yeah, that's the idea, so that we get rid of the copious amounts of redstone lamps in my inventory. So if this works, we should be able to display stuff. Like, if I want to, I could make Tetris, or I could remake those with these. So next, it is to build it on top. There we go. Boom, 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 boom. Drag this all the way down. Repairs. And then we have a new problem. Great. Great. Nice. Very nice. Very demure. Very demure. Is it control right click? Alright. I want to just light up like these 4. But I guess that's what we're working with. So A1, ABC, C2. Then we got a staircase. Yep, and that's the annoying part. So now the idea is to get one specific one. So my idea is to subtract them. So if we want repeater 1 here to activate, you have to do a bit of subtraction. And we can put these in series. Can I do it just like this? Where I could probably do it something like this, where it's just minus that. Oh my gosh, I have copious amount of redstone lamps to get rid of. But yeah, Rain, that's one of the fun parts about this. It's kind of like coding real life, you have to figure it out. And it's more tedious. So I guess we're going with this type of situation where this is our problem. And again, is there a way to just like, no, C plus 1 x2 x3 x1 x2? That's a hotbar. So I could have it like okay, what I'm gonna do is I'm gonna have C1 as this. So that's I'm gonna set it in a way. So if we want the RAM, we have these. Okay, wait, the lever. C1. If we want this, then it will be glass, white wool, sticky piston, redstone lamp, don't need this, redstone torch, and what else here? Target block. C2. Oh yeah, if you look at the difference between this one and this one, you can see the evolution of how it started off. So you see how this one is really simple and a lot less compact. Then you have this one, which is more complex, but it is adaptable. Then you have this one, which is just about a direct copy, but has inversion because it is practically 0011. Then you have 0100, which is a new type because now you have target blocks, and also I finally remember the term for this, quasi connectivity, and it is quite literally the remake of this to make it better. These were changed to target blocks later. This is meant to cut off flow, and then this was changed. It continued on for a bit more. Then we got to the next series, and we had to have an upgrade. So now we're up to this generation, where it is not more simpler, but it's simpler in encoding. If I want to flip this bit, I'll have to do this. If I want to flip it again, I can just do that. If I want to flip this, that. If I want to flip it again, that. And it's really simple. This carries the power, which I call the main bit. This has to be on for it to work. Then it passes through this, which has to be off. Then goes through a repeater, then to a next target block, and this line has to be on, but this is 0 1 1 0. Subtraction, by the way, is practically inverting all this, but yeah. So then we go to the final piece, which is the remake of this one on this side, which then lets it pass through to this, and then I have to do a lot more complicated stuff, which is called connect all this to this. And mind you, we have 26 letters in the alphabet. I'm at number 10 register, and we will need more of these, so we have to extend this back. At the same time, I do want all these to be connected, so I'll have to modify them again. This will instead be something similar to this. This will be extended all the way back here, and this will have to be repeated for the entire thing. But yeah, we can't also forget numbers, because we're gonna need to go from 0 to 9. So that's 10 numbers that we have to add, which is, let's see, 36 values. Then, if we want special characters like backslash, colon, semicolon, or quotation marks, then let's say backslash, colon, semicolon, and quotation marks only. That's 40 of them now. If you have to quadruple this. So you see how very fast this is getting more and more complicated. And that's why I want to compact it, because imagine I continue with the open design. That's going to take up a lot of space. I don't want to make this seem messy, and that's also why I also want the ALU, not ECU, to fit inside here. I want this to be as simple as possible, and I want my ROM for it to also be simple. So all this needs to be taken into consideration just to get a working screen, ALU, storage to some degree, RAM, and computations, because we still do need to make instructions for it, which will be placed in the CU, and then that will coordinate everything. Then we'll have our first prototype for now of the computer with a clock that I'll make later on. This is probably going to be like a 20-part series or something, depending on how far I get. But we'll see how this goes. Because in this stream we are going to cover screens, RAM like I did over here, and then probably even more RAM, just 3-dimensional for storage, and a lot more tutorials. So without further ado, let's get back to this part of the software, the display. Our goal is to take this, we can implement our ROM backend later. Then we can take this and then extend it, because if we can get this to be like a multifunctional display, then we can not only display characters, but we can also display like images. So like the project Minecraft in Minecraft, yeah, we can make that, and it's programmable. At the same time, if you wonder about randomness, put a chicken with some tripwire or something, and give it tick speed 100. There you go, you got randomness. We just gotta wait a bit. And you could like give it splash potions of healing or something. But at the same time, if we can get the computer to work and also have outputs, we could make specialized programs. So we can make programs that predict where the end portal is. So like we could say, okay, we want to know where the end portal is. We can take our entire computer, paste it into the world, make a simple program that calculates where the end portal is, and then we can say, okay, process, and then it gives us it. The only problem with Redstone is it's stupidly slow. So if I were to go to tick speed 20, this is how slow it is just to get C. So let me just freeze it. So if I want C, this is how slow it is. Now imagine you have something that's all the way down here. Because remember, we have over 40 characters that we have to deal with. And we're going to ignore shapes, because that's going to reach 100 at some point. So yeah, our memory is not as dynamic as we thought. The average computer has gigabytes. This computer will have bits, not even a byte. 1 kilobyte is like 1,000 bytes. 1 megabyte is 1,000 kilobytes. 1 gigabyte is 1,000 megabytes. 1 terabyte is 1,000 gigabytes. So imagine having a single gigabyte. Imagine how big that's gonna be. Your computer is so fast and so compact that this is just incomprehensible if you were to just not know about computers. So imagine the constraints with Redstone, because we have less constraints. If you were to turn off your computer, especially if you have RAM, then turn it back on, the RAM would clear because there's no more power. In Redstone, that's not a problem, because our power turns on and off just so that we can use it. So imagine this in a computer. It's like microscopic. Like, you could barely see it. Like, even like way smaller. If I had my render distance very high, I could have. Like, imagine that can hold 4 bits, not 2 bits, not 4 bits, 2 bits, not 4 bits, a combination, which would add up to 4 or 5 if 4 if you're counting 0 0, 3 if you're not counting it. And imagine you want 16 gigabytes of RAM. They have to be glad Minecraft World is infinite, because imagine that much RAM needed just so that you could play Roblox. Imagine that Roblox takes up a gigabyte of memory. A single gigabyte. That's gonna be torture. And your computer does it within seconds. That's just why this video I watched on computer science says your computer is a genius with the memory of a demented goldfish, because it cannot remember a single thing. And to think it all does math. Math, logic, and displays hundreds on thousands of pixels. 4K TV, that's 4,000 pixels working in unison to make you see your screensaver. And imagine multiplying that by 3 for the RGB display. RGB. 4 times 3 is 7. That's 7,000. And imagine this is 1 pixel. 7,000 is a lot. And imagine having to hook up an entire display, like stuff to connect it, and all you can do is do it one by one, because this is T-Launcher. I can't really use mods on this. So I've been making this by hand. I can't use MC schematic. I can't use replay mod or anything. I have to do all this. So it requires dedication for this stuff. And it's sad, honestly, because this is a pain. A good chunk of this stuff is just to perfect this. My God, this is suffering. Then imagine having to connect over 100 different ones to this. 100 ticks per second, sorry. Will start being a bit slow. We're gonna throw it to 200. And a 7-segment display is not gonna help us for shapes. So we're switching to pixels, and then maybe in the future we'll do RGB display. Maybe. Probably gonna have to downscale for RGB because that's a bit too confusing. Just now. To be honest, I don't know how MatBat does it. He just does. Because this is confusing. To be honest, I might at some point try to upload this to a server so that people who want to help with stuff like, even if you want to program, like a program for it, that would be helpful instead of me having to try and figure out what to make. Because MatBat made a multi-line renderer. I don't know how to do that. I know how to program. I can do Python, but I can't do multi-line render. So yeah, when you see a Minecraft program, don't say that's easy, because trust me, it's not. Not by a landslide. Alright, so let's get back to business here. Our goal is make a display and make RAM, and then turn that RAM to storage and make that storage permanent. Well, kinda. This is what happens when I don't use a mouse pad. But okay, so let's try and. So our goal is to get a 4 pixel here. And Then let's do that. Oh my gosh. I'm gonna stop using barrels. I'm gonna use shotguns from now on. But yeah, so let's change this to a target. Boom. Now we have that, which we can use. And it works in unison. Nice. So if I were to hook that up, so now we can actually see it properly. 1 pixel. And next we do that like this. And you already see we're running into a problem. This is here. You can't do that. So what we're gonna do is this. Actually, no. How did MatBat do this? I'm confused. I'm horribly confused right now. I'm probably gonna do it like this, and then like this, and boom, we have less suffering. Then we just do get rid of that. Then we route it again because I forgot to do that. It does have a nice animation though. I admit it's not on purpose, but it works. It's not there. That's better. So now that we've shown how we're gonna get that, next it's to go up. So what we're gonna do is the exact same thing but stacked. So we're gonna place that there. 2 target blocks. Then, because of how it's designed, we don't have to worry about that part. Then we can combine it. Add a torch. Then we can technically write a program here where we can do this just now. Alright, I'm back. So we got our pixels here to work, and now we can assign them specialized values. So now we're gonna look like we are from Germany and do something like this, and let's hopefully not have to route them like, no, I'm not gonna do that in the first place. Alright, so let's take our values here. This will be the bottom value here, and we're gonna route it inward, route it into this bottom value. Here. Okay, all the pixels are still working. Okay, next we'll be going up. Crouch. No, I cannot speed bridge. I can't speed bridge if my life depended on it. Okay, and lastly, we're gonna just go up here. Wait a minute. Isn't that, no, this one. Oh no, 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 no. You saw nothing. And why did I keep getting stuck under that? There we go. So now we have this encoder here. So we want top pixel, bottom pixel there. So you see how this can be used for a display? You could create like this. No, that's the wrong one. We could create like a font for it, custom, and then we could just change the coordinates based off of the coordinates already there. So if we're in C whatever, we could start there and then place all the values based off of the starting coordinates, the coordinates of origin. And then we don't need this incremental one anymore. And we can forget how annoying this was. This could probably be like a progress bar. But okay, let's continue to add more pixels. Watch how complex this already gets. This is a 4x4. We're going for an 8x8 now. So this is 1, 2, 3, 4. Need one more layer. There we go. 8x8. And now we can also make letters. Because for A we can just do this, 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 this. Stop here, go over here. This, 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 and then have it cross to the middle. Or we could make it 1 pixel here. And like 1 pixel wide. Have another pixel gap here, then have this. So let's get rid of the German wiring here. And after we get a solid display, way to display stuff, we can focus on coding it again, encoding it again. So this entire row has to have that, this entire row has to have that, this entire row has to have that, this entire row has to have that. Then we realize our mistakes, get rid of our progress, and then do it the proper way, which is to do it like this. Target, where's the target? Over here. That should be it. Next, we line this up with torches. Then we should have zebra lines. zebra lines, however you want to say it. Alright, now it looks like the opposite of the America right now. It's supposed to be on top. Okay, next we're supposed to actually put in these now. Boom, 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 boom. And then we have these. Then we should have an entirely lit display except for this section. Then we do the easy part on the ground. Realize that's not easy. That's still difficult. Because guess what? Why did Microsoft Store open? Like I said, because guess what? My laptop's, where's my laptop? Like here now. Can't do that. Can I? Can I? Can I? I can make it alternate. Ah, yes. Boom, boom, boom. This pixel, I did not invert it. I did not invert it. Okay. Next we have this one. These 2 pixels. Next we have this one. All 3? No. It has declined my request. Never mind. And then we place this on the ground. There's a problem with this design already. If you ever noticed, you have to do it like this. Oh, mate, watch it. Ugh. What if I do this? Aha. Can't do nothing about this now. Can it? Neither can this do anything about it. Guess. And then that powers 2 pixels. So, what if I do this? Off. Come on. And then if I do this on, yes. Then I can let that suffer. And then repeat. don't need to. Just need to do. So I in fact do need to do this. I know a perfect way to get this. Boom. Now it's safe. Bruh. You know what? I'm gonna redesign this entire thing before I crash out on this. Alright, so basic principle. This goes into that turns off that turns off that. Perfect. Then this has to go here. Put that there. Put that there. What if I just do this? Hey! No crashing out needed, guys. It's safe again. Invert. Top one on bottom one. Kinda on, kinda. What's wrong with this? What's powering this? Do my own thing, only to discover that's not an option. Bow, 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 hey now, you're a rockstar, let the show on, go play. Hey now, you're a rockstar, put your game on, go play. And all that glitters gold, only shooting stars break the mold. And all that glitter is gold, only shooting stars break the mold. The only problem with this design here is the fact that it ain't gonna work. If I go up here, I can't come back down. If I go there, I can't come back down. I need to find some way to get this to set itself. Can I just use a powered rail? Alright, I'm interested. Oh, damn, I've been streaming for a bit now. Alright, so the idea is to try with powered rails. I guess that's enough. Can I use sticky pistons with these? No. It's just like converted and then can't be converted back. Looks like it's time for another tutorial.
Say that the bottom left pixel has the coordinate 0, 0. Then for every pixel to the right, x will increase by 1. And for every pixel up, y will increase by 1. For example, this pixel right here is 2, 3. 2 in x and 3 in y. To plot a pixel with just an xy coordinate, we can use something called a matrix decoder. A matrix decoder takes in two numbers, x and y, and outputs the corresponding point. Right now, the input is 0, 0, so that's why the bottom left torch is on. But if we input, say, 4, 5, the torch at the coordinate point 4, 5 gets turned on. This works by using a decoder for x, a decoder for y, and a grid of torches to detect the intersection between them. Notice that every torch in this grid is being powered from two places. The row with these redstone lines, and the column with glass towers in the back. Now, since x is currently 4, the 4 line on the decoder gets unpowered, which stops powering that column. And since y is 5, the 5 line on this decoder gets turned off, which stops powering that row. So, the torch where the 4th column and the 5th row intersect is the only torch that turns on. So
I feel very stupid. So basically, we could have always just done something similar to this. Can glass be powered? I don't think so. Nope. It's what we do. This. Somebody once asked, could I spare some change for gas? I need to get myself away from this place. I said, yeah, what a concept. I could use a little fuel myself. Just all nothing. Why did I go so high up here? 3, 4, 5, 6, 7, 8. Perfect amount. Then we put a repeater for each one. Then we also take this yeah, that doesn't make sense. How am I gonna get this one? So that's just deactivating that, so yes, my brain is finally braining. That's a lot more compact. What if I want to deactivate that gives me that. So So what if I want this and this? Isn't that deactivating the same torch? Oh no. It's just accidentally activating two of them. Why is it not going downward? It's just not want to go down. Hey, don't be directionist. Don't be directionist. The fork. Nope, no, don't do that, don't do that. Place that back. That's not how you place. Alright. So, we select this column. And now we have the option to drum roll, please. Insert drum roll. Just done. Now we have the option to select different cells. So now we can create lines. Why aren't you clapping? Aren't you clapping? It's definitely a breakthrough in technology. Trust me. It probably is. Yay, we'll clap. Hey, he's clapping. Let's go. Probably can just do this. And then all we do is just switch that. Seriously. If I just make this out of glass. Wait a minute, then I can't turn this off, can I? If I were to press this, that stays on. Oh yeah, thank you for the clappy and troublery. So yeah, if we do that, and we're gonna have to do this the hard way. It's called switching back to the tutorial. So now, how do we get this? So if I wanted to do the bottom one for the next side. I'm gonna just try to figure it out. Wowzers, guys, it turned on without any other complications, like definitely. Like this was so simple. Like I'm the best at Redstone, aren't I? Like I'm the best at Redstone here. This is so simple. And next problem. If I just try making it like a grid, I'm gonna try a grid. So layer 1, let's see. Nope, that's supposed to be this here, and then that. Okay, so now we have a column. Okay, so 3 spots. Three spots. 9 spots.